Happy Monday. What a good Monday it is. My kids are finally back in daycare. Freedom during the day now. What did we do on Wednesday? Feels like a lifetime ago. We did,
Lots of increasing and decreasing intervals.
right, behavior of a graph, right?
And
Average rate of
symmetry.
change, yeah. Behavior of graphs.
Yeah.
Today, we look at function algebra. There are technically there's only 3 basic operations. But we'll say 5 to be rebels. Addition, subtraction, multiplication, division, and then function composition. Ready to have your minds blown, or I guess more or less be ticked off because you've been lied to your entire lives. When dealing with arithmetic, how many operations do you have?
You told us this. There's really only 2.
Oh yeah, did I?
Yeah. The subtraction and division are
Yeah.
just opposites.
Right, so technically, function addition, function subtraction, function division are not really. But we'll deal with that. Whenever you combine functions, the domains change. So when you add 2 functions together, you get a new domain. Subtract 2 functions, multiply, divide. For the most part, the domains are easy. For addition, subtraction, and multiplication, the new domain is simply the intersection of the domains. It's what the domains have in common. Division, there is one additional caveat. Denominator can't be 0. So you take the intersection, and then from that you remove all values that make the denominator 0. That make g of x equal to 0. Function composition is even more fun when trying to find the domain. We'll look at that a little bit later. So here we're given 2 functions f and g. We're going to find the 4 basic operations on them: f plus g, f minus g, f times g, f divided by g, as well as state the domains. Being able to state domains, again, is very important, simply because a lot of the time the domains are going to be implied domains. Right? So when you're dealing with a problem, you want to be able to determine what the domain is. So this is important. Let's start by stating the domain of f and the domain of g. What is the domain of f?
Negative infinity, -2. Union to infinity.
You're missing a piece.
Oops. Negative infinity, -2. Union. Oh, wish. Two.
Why are you excluding values between -2 and 2?
Because they'll, of course the denominator could be negative, just can't be 0. Oh, okay, there you go.
That's the piece you're missing.
Okay, so you gotta do, okay, 3 sets with unions, 2 unions.
So everything except for plus minus 2, right? Everything except for when the denominator is 0. What about G?
This can't be 0. Negative infinity 0.
So everything except for 0. There, those are the domains of the functions. Yes. Remember, the denominator is not allowed to be 0, right? So when is x squared minus 4 equal to 0? That is the function f plus g. It is a brand new function. And boy, is it difficult to find.
We gotta do, as a single complicated fraction, right?
Well, yeah, we're going to have to do that. Of course, by difficult, I mean it's actually not difficult at all. You just add the two functions together. That's just
Well,
plus j.
Yeah. No, it's just the adding of the
Actually,
fraction.
my sarcasm level is
Messy.
nonsense. It's not like they're
Well, it's not messy to you with your
What-
Calc 3.
what am I thinking of? It's not like it's a fractal. Ooh. Those are messy. And actually, calculus is easy. It's this stuff that's difficult, as you'll soon find out. Remember, what do we have to do when we're adding fractions? More specifically?
Please.
Which is x times x squared minus 4. Distribute the x through in the first term. And just to be safe, I'm just going to put parentheses around the two terms. It's not necessary, but then distribute that 2 through. Oops. And we'll distribute that x through in the denominator. Because that cannot be simplified. There's f plus g. Now we need to state its domain. As I said. The domain of f plus g is the intersection of the domains, which makes sense, right? You can't add two undefined terms. So f plus g is defined only when both f and g are defined. Intersection of sets is everything they have in common. Let's see. This is everything but -2 and +2. This is everything but 0. What do they have in common?
Everything except the 2's and the 0.
Everything but -2, 0, and +2. Oops. So there's your domain. F minus G. Just f of x minus g of x. This is where I get to pull instructor's prerogative. By the way, you can do the exact same thing because you're on the tablet. It's a very nice feature. Take advantage of it.
Oh, I had my head down. I missed it completely.
I wrote that entire thing out in a second because I'm just that good. Look how fast. Because that's the only thing that's going to change, right? That plus is a minus. All the other work is the same. Of x squared plus x plus 8. Now again, be careful. Because that is not the same thing.
Shit. Sorry. What's not the same thing?
I erase the parentheses down here.
Oh, yes, of course, because you got to distribute.
Yeah, but again, you'd be surprised at how many times students will not write the parentheses. They forget them and then they don't distribute the negative properly. Domain.
The same.
It's the intersection.
Same denominator.
The domain is identical. So f times g of x and also written f dot g, right? Have to be careful though if you're going to use that dot because you don't want it to look like a minus and you want to make sure it's filled in. Because if it's not filled in, that's something completely different, as we're going to see. And a lot of times, if you actually do have to code, you have to specify that that's multiplication and not a single variable. I can tell you for certain that Mathematica, if you just put in FG, it's going to read that as a single variable and not as F times G. It's just f of x times g of x. How do you multiply fractions?
Top, bottom, times bottom.
Straight across. Sadly, there's nothing to simplify, so there is an answer. So there's f times g. And its domain is the exact same thing. It's the intersection of the domains. Again, it doesn't make sense to multiply a number by something that's undefined, right? So you have to make sure that both terms are defined. So f divided by g. Big surprise. F of x divided by g of x. Or f of x over g of x. How do you divide fractions? What gets multiplied by the reciprocal of what? And then it just becomes a simple multiplication problem, right? Where you multiply straight across. And again, there's no simplification, so that is our function. The domain. Domain of f intersected with the domain of g. Minus the set of all x in the domain of g such that g of x is equal to 0.
And that backslash is.
Set minus. And what it says is you look in the first set, in this case, the intersection, and you take out everything in the second set. So we know that first set, right? We know what the intersection is. It's everything except for -2, 0, and +2. The question now is, all the values in the domain of G, everything but 0, for which of those values is G of x equal to 0? What do you mean by the last one?
The last problem. Hey, what was your question?
Take a look at all the elements in the domain of G. So everything except for 0.
Right.
Which of those elements makes g of x equal to 0?
None of them.
Why?
Because you can't divide two real numbers and get 0 as a result. I don't know if that's a rule, some kind of rule. I mean,
You're right. Well, no. You're almost right.
really?
What's 0 divided by 100 million?
Oh, of course.
0 is a real number.
Yeah.
The only way you can divide two real numbers and get 0 is if the numerator is 0. If you were to try and solve this algebraically, this is what would happen. You'd say 2 over x is equal to 0.
Yeah. Cross multiply.
Which means 2 equals 0, which is nonsense. If 2 is equal to 0, then all of math as we know it is wrong, and I'm going to have to go back to kindergarten to learn the basics again. This is what we call a contradiction. It's a contradiction. A contradictory statement is a statement that is always false. Right? I can easily come up with a statement. The sky is green and you all pass is a contradictory statement because the sky is not green, so it's always false.
So, all right. So the domain of f over g of x would be basically d of f, right? Because you can't have zeros in there.
It's the same thing.
I mean, yeah, it's not always going to be d of f, but in this instance,
Well, it's not just df. It's the same as what we've had before. It's the intersection only.
oh, and zero's not in there.
Right, because again, you can't divide a number by an undefined term or vice versa. Right, so both f and g have to be defined. Right, so that is only because this set here is the, is the empty set. The empty set is the set that has nothing in it. So there's nothing to take away. Right? Technically, it was 4 parts, right? Because we have to find 4 different functions. What is the domain for f?
Negative infinity to 1.
Open or closed?
Oh, sorry, well, open on the infinity side and closed on the 1.
Because remember, that's a square root, even radical. You can't have a negative. What about domain for G? Set infinity. Two to infinity.
Like -1 to infinity. -4 is 1.
Well, it could be negative, I mean, all the way down to negative infinity, right, open-ended. It'd be negative a gazillion. And a square,
Agree with that.
all the way to -2 closed. Because if it is -2, then x squared is 4, and you get root 0, which is okay.
Now remember, you're squaring it. So if you square a negative number, it's positive. So you just have to make sure the square is no less than 4.
We're trying to equal the G to 0.
X squared minus 4, you want to be less than or equal to 0. Or greater than or equal to 0, sorry. Right, you don't want it to be negative.
I mean, I always start by figuring out what makes x squared minus 4 0.
So for F, right? There is negative open and infinity to 1.
Mhm.
That's because there is. The neg,
And so 1 minus 1 is 0. What's 1 minus 2? Which you can't have. But 1 minus 0, 1. So x has to be less than or equal to 1.
Like if x was -15, then it'd be positive 16 under the radical. 1 minus -15. The union, yeah.
All right, so domain for G is everything except the values between -2 and +2. Right? Square any number between -2 and +2, you get a value less than 4. Which would make what's under the square root negative, which you can't have. So there are our domains. So f plus g, f of x plus g of x. Can that be simplified? Because that's what we're trying to find. You think that can be simplified? How? Uh-oh. We don't remember algebra. That's not good.
I don't either. I like I'm doing math.
I remember algebra.
If you can't because of the exponent.
This cannot be simplified. Square root of A plus square root of B cannot be simplified, right? And again, sadly, I have a lot of students in like higher calcs that go, oh, that's just square root of A plus B. No. Square roots do not distribute across addition or subtraction. They do, however, distribute across multiplication and division. But not addition and subtraction. Yep. You don't have like terms. Each square root, think of each square root as a single term.
But if we were multiplying those two,
That could be simplified. And there's no reason to ask if, because we are going to be multiplying them eventually, right?
wait.
So
Saying no.
the domain is the intersection of our domains. Again, it's what do they have in common? So what do those two intervals have in common?
We definitely both start at negative infinity. Open.
And where is it going to end?
-2, close.
Is that it?
Intersection.
So that'd be your domain? You don't want to add anything else to it?
Intersection. No.
No?
None of that.
That's
two to
it.
Infinity is part of F.
That's it. You can immediately eliminate 2 to infinity, right? Because that's 2 is definitely greater than 1, which we can't have. So that's out. You can't have 1 because 1's greater than -2, which you're not allowed to have. Right? It has to be less than or equal to -2. Right. Well, all of those values, so all of these values in here fall within this interval. So that's your intersection. So f minus g, f of x minus g of x. The power of technology, I don't have to rewrite it. Again, that cannot be simplified. Okay. And the domain is the same. F times g, f of x times g of x. This can be simplified. Right, so square root does distribute across multiplication. Right, that is root A times root B is the same as square root of A times B. That means you get to do the dreaded 4-letter word that begins with F.
I love FOIL.
FOIL. Good. I didn't get a single snicker, so no one has their mind in the gutter. Now I have a couple snickers, so now I know whose minds can go to the gutter. What did I have? Negative x cubed plus x squared plus 4x minus 4. The order in which you write it doesn't matter. I just always like to write it in descending order. Negative x times x squared. So I didn't really do FOIL. I didn't do firsts, outers, inners, lasts. I did what? I did the inners first. Then I did the firsts. Then I did the lasts, and then I did the outers. So what's that? If all. Domain's the same.
It's gonna be same for everyone.
Not everyone. F over G. F of x over G of x. Again, that can be simplified. Because again, square root does distribute across division. Right, so root A over root B is the same thing as root of A over B. Domain. The intersection of the domains minus all values in the domain of G that make G of x 0. Right, so we already have the intersection. Right, that was from the previous 3. So now go back up to G of x. Look in the values in the domain for G. Which of those make G of x equal to 0? Plus or minus 2. So if I write this out, that's what it would look like. Negative infinity to negative 2 minus the set of negative 2 and 2. What this means, look at the interval negative infinity to negative 2. Is negative 2 in there? Take it out. Is 2 in there? So we don't have to worry about it. So we're removing negative 2, so that no longer is closed, it's now open. That's what set minus does. Notice here, for division, what did actually, I think it would still work out when if you just looked at it and tried to find the domain of the function without considering the domain of f and the domain of g, you should still get minus infinity to minus 2. Nice. All right. So that's enough with the familiar operations. Right. Addition, subtraction, multiplication, division of functions works almost the same way as if you're just doing basic arithmetic. This should be your first look at a new operation. Composition. I guess technically you could argue square root's an operation, right? I would argue raising it to a power is not, though. Function composition. And again, we're going to want domains. So let's just start by finding the domain of f and the domain of g. What is the domain of f? You're saying I'm tired and drunk. That's a nice combination.
Very collegiate. Close interval 6, open interval infinity.
I was drunk.
Monday, man.
Monday's usually hangovers.
Ugh.
But that's the morning. This is an afternoon class. Huh?
See what you did there.
Oh, I teach morning classes too. And actually, afternoon class might be more dangerous because that gives me all morning to drink. Oh yeah, I had a professor who did that, came in completely hungover and said, yeah, screw that. Canceled after like 15 minutes that I'm never drinking before class again. He even took us out to drink as celebration of us graduating. That was fun. What is the domain of G?
Everything.
Yes, it's everything. Excellent. F composite with G of X. Sometimes read fog. I don't, because what if I go the other way? Then it's like golf. Or if I do like A composite with B, AOB, I mean, it just doesn't make sense. So this is function composition, right? That's what the open circle means. Right? Which is why I said if you're going to do the dot for multiplication, you want to make sure it's filled in. Because if it's not, it represents composition. This operation is also very simple. It's f of g of x. Well, g of x was x squared plus 5x, right? So it's f of x squared plus 5x. Of course, that means ever you see an x in f, replace it with x squared plus 5x. There's f of g. Domain of f of g. It's the set of all elements in the domain of G such that G of X is in the domain of F. Right, so it's all values in the domain of G that make G in the domain of F, right? So would it make sense if you plug in a G of X that would make F undefined? But here's what we do. Take G of X. This in H. We want this to be in the domain of F. What's the domain of F? Which means, oops, not 2, greater than or equal to 6. Solve for x. And right is a quadratic, greater than or equal to 0. Or less than or equal to, depending on the interval, doesn't matter. Because we've solved this before, right? We did this when we looked at domain and range. You need to find the breakpoints. Those are all the points where x squared plus 5x minus 6 are equal to 0. Can that be factored? What is it factored to? Is it x minus 1, x minus 5? I agree with the x minus 1. X plus 6. You mixed up your 5 and your 6 when you were doing the factoring. That would make x either -6 or +1. Those are the breakpoints. Right? Now we just set up our intervals. From -infinity to -6, x squared plus 5x minus 6 is negative times negative, which is positive. Go away. -6 to 1, we get negative times positive, which is negative. And then 1 to infinity, we're going to get positive times positive, which is positive. So the solution is -infinity to -6 unioned with 1 to infinity.
What is the name of the E thing again?
Just means in.
Just means M.
Right, so x is an element of, which is another way of saying x can be any of those values. These values guarantee that g of x is in the domain of f. Which of those values are in the domain of g?
Domain of G?
Yep. All of them, because g was all real numbers. So that happens to be our domain for f composite with g.
So wait, so the last thing you have to do is check that X element.
Yep, so then you just take all the elements in the domain of g that satisfy that, which happens to be just that, because g can be any real number. We now want g composite with f. Well, that's just g of f of x, right? F was what? Root of x minus 6? So it's g of root x minus 6. Which means everywhere there's an x in g, replacing it with root x minus 6. What is the square root of x minus 6 all squared? Just x minus 6. Right? There's g of f. Its domain. Set of all elements in the domain of f that make f of x in the domain of g. Domain of g. all real numbers. Right? So we need values in the domain of f that make the square root of x minus 6 a real number. What's the square root of a real number?
Square root of a real number?
Let's be more specific. Square root of a
Non-negative?
non-negative real number. I can say real number because I'm dealing with domain of f, but non-negative real number. You take the square root of a non-negative real number. What's the result? You're overthinking this. It's still a real number, isn't it?
Okay, yes.
So the entire domain of f is our domain. Every single value in that domain is going to give you a real number for f. Yeah, because that guarantees that x minus 6 is non-negative. Right? So you're always going to take a square root of a non-negative number, which is itself always a real number. That's the domain of g of f. My, it's been an hour already. How time flies.
Been cruel.
Been cruel. Well, you just failed. You didn't get the ending of what? Oh, this here. Okay, aren't you updating? You. Same question, two different functions. Start the same way. What is the domain of f?
Oh, all real numbers.
Everything. X squared plus 5 will always be non-negative. In fact, it'll always be positive. You can't even get 0 out of this. Right? What about g?
From -2 to +2, closed on both sides.
Right? -2 to +2 closed.
So with those numbers, it mean that it'll equal 0, right? Which, like, if we plug in the -2.
That'll be 0, right?
0.
2 will be 0. Well, it's everything between -2 and 2. No. So it's 0, it's 2, right? So because it can equal 0, that's why they're included. But everything in between -2 and 2 will give you a positive number. Under the square root, right? Which is what we need to have. F of G. F of square root 4 minus x squared. Ever there is an x in F, we're going to put a root 4 minus x squared. So you'll wind up with root 9 minus x squared. G of x in the domain of F. So we want values in the domain of G that make G of x in the domain of F. Okay. For now, let's just say I gave you that function. What would you say the domain is? -3 to +3, right?
Close.
Is that what our domain's going to be? Yeah. So elements in the domain of G, -2 to +2. We want G of x to be a real number, right? Because that's what the domain of F is. Doesn't every value between -2 and 2 make G of x a real number? That's our domain. The domain is not -3 to +3. Right? Because anything less than -2 makes G of x undefined. And this is a composition. You have to be careful. When dealing with compositions, you can't just look at your final result and try and determine the domain from that. As you just saw, you'll get something different. In general, you always want to just do that whenever you're doing a new function. Don't just look at that function, right? If you're multiplying functions, do the intersection. Don't just look at the resulting function. G of f. G of the square root x squared plus 5. Means everywhere there's an x in G of x, we're going to replace it with root x squared plus 5. That will give us what? Like negative x squared plus 1. It'll be negative x squared minus 1.
Yeah.
So negative quantity x squared plus 1.
That's gonna be a problem.
We want values in the domain of f that make f in the domain of G. In other words, we want -2 to be less than or equal to square root of x squared plus 5 to be less than or equal to +2. That makes 4 less than or equal to x squared plus 5 less than or equal to 4 because you're squaring both sides. That actually means x squared plus 5 needs to equal 4. I mean, x squared would have to be -1, which is a contradiction. That means our domain's empty. Which you can also interpret to mean that this is not actually a function. Because it doesn't have a domain. There are no values that make this defined. I should clarify that. This is not a real valued function. It is a complex valued function, though. But yeah, that's for senior level math.
But I mean, as soon as you saw the radical with negative some quantity, and there's no way to make that quantity equal 0. So in other words, you have a negative under a radical. I mean, don't you know right there the domain's going to be empty set?
I know what you're trying to say, but you said it wrong.
Okay.
Who cares if it can't be 0? -8 is positive, which would make this defined.
Yeah, but you can't create a -8.
That's what you wanted to say.
Of an x squared plus 1.
There's no way to get that to be non-positive. That's what you're trying to say, not just.
Well, there's no way you can make the radicand non-negative.
Right. There's no way you can make x squared plus 1 non-positive, what I'm trying to say. Right. Yeah.
Oh, yeah. I got you. Yeah.
Right. Doesn't. Who cares if you can't make it 0? Right. That's not necessary. The fact that you can't make x squared plus 1 non-positive is the key.
All right. So you just take the f of x, put it in between the compound inequality.
Right. So this would be algebraically how you would explain it. So there are 2 ways to represent the empty set. I have one up there. The other way is Just the races with nothing between them. By the way, that is not an empty set.
It's a set of sets, right?
Because that's the set of the empty set, which means there is an element in it, the empty set. So that is not an empty set, so you have to be careful. Set theory is fun.
Isn't that guy Cantor? Isn't he big on that stuff?
He has a set, the Cantor set,
Yeah.
which is fun.
Explode.
You really want a famous math guy, look up Euler.
Oh, of course.
If you invent a new math, he already has a theorem in it. So we just did function composition. An important skill for calculus is going to be the reverse. You're going to want to decompose a function. In other words, given a function, you want to find two functions, f and g, or possibly three functions. In this case, we're just going to deal with two. So you want to find two functions, f and g, such that y is f of g of x. Again, this is very important for Calc 1. And there may be more than one valid answer for these. What should we choose? Let's do our inner function. So what do you want g of x to be?
5x minus 3.
Then what would f of x have to be?
Next to the fourth.
There's a decomposition. And in fact, if this was a calc class and we were doing chain rule, that's the decomposition I would use. No, you're the one who gave it to me, so break it down.
Well, I think of 5x minus 3 as a chunk, right? I think the whole quantity, I call it chunk. And I'm thinking y equals chunk to the fourth. So one of these functions is chunk, I'll make it x to the fourth. And then what is chunk? Well, that's g of x. Chunk defined as 5x minus 3. So I looked at it as chunk to the fourth. One function is the chunk. The other function is x raised to the fourth.
So how did you know that the chunk was G and F was?
You just make it.
Well, I mean, the F and G is what the problem told me, so I just figured I'll call the inside let's say, g of x equals chunk. So g of x is the chunk, and then f of x is chunk to the fourth. So that's how I think about it, is chunking.
Did you get a teacher explanation? Sorry.
Of course.
So you're also a teacher. I'm sorry.
No.
I don't know if my explanation is going to be any different because it's very similar.
Would you do it?
Oh, yeah, just without using the word chunk.
I just look at it and I go, okay, what's the overall function? I see that as a power function to the fourth power. So outer function's x to the fourth. What's being raised to the fourth power? That's your g of x. That's how I look at it, which is the same thing as what he was saying.
Yeah.
Just with the word chunk thrown in, because I like chunk.
But that's not the only answer.
Could you do it opposite ways? Like if fx could be the 5x minus 3, and then the gx could be the x. So
Yes, but then it wouldn't be following the instructions, which specifically said f of g. Right? The way you did it would be g of f, which is valid, but that's not what the instruction said.
So to give partial credit.
Yes.
I'd underline the instructions, give you a 0, and then put a sad face.
Yeah. So I'm guessing like because the g of x on the inside, you see where like y equals f, for instance. It would be g of x because the g of x on the inside.
Okay.
Yeah, y is a function raised to a fourth power. That's how I look at it. And again, that's how
Then you can't.
chain rules taught.
Yeah, you can't like raise nothing to the fourth, so.
Well, I mean,
It can't just be like a floating.
well, yeah, you can't raise nothing to the fourth, right? But 0 to the fourth makes sense. So you have to be careful because some people would say 0 means nothing. But yeah. So for instance, another decomposition could be f of x is x squared and g of x is 5x minus 3 squared. That would also be a valid decomposition, right? So there's more than one valid decomposition for this. Try to look at it the way that was just explained as an outer function and an inner function, because for calculus and chain rule, that's how you're going to have to do it. So again, I look at this and I go, well, this is a power function. Now, technically, it's not. Power function has specific meaning, means the power is an integer, positive integer. For calculus, this is a power rule, so I just call it power function. It's a radical, right? So I'm going to say f of x is the square root of x. Right, because we're taking the square root of a function. Then g of x would be that function, 1 minus x squared. That would be my decomposition. Again, it's not the only valid one. I could let f of x be x, and then say g of x is just square root of 1 minus x squared. That's always a valid decomposition. It's not bloody useful, but it is a decomposition. What else could I do? I could do f of x as x squared. And g of x would be the fourth root of 1 minus x squared. That would also work. Square of fourth root, you get square root. But again, that's not really useful in calculus. What do we think? And trust me, by the time you get to calculus, you're going to be doing so many of these that you're going to be able to just look at it and immediately see the decomposition. I wouldn't. I wouldn't.
You could just say that the chunk, the parentheses, f of x is x squared minus 5x plus 6. And then
F of x is that?
f of x, no, g of x is that. Is the chunk, and then you just, f of x is just x to the 2/3 power. Shit.
No,
Oh, 1 over x is a 2/3. Ah!
I would also accept x to the minus 2/3. Yeah. There's your decomposition. Again, very important skill in calculus. You'll be doing it so much that, like I said, you'll look at these and it'll take you 5 seconds, less than 5 seconds to come up with the decomposition. By the way, function composition is not just for 2 functions. You can also do like an f of g of h,
I know.
which is still the same thing, right? It'd be just find g of h first, and then it's f of that.
Masochists
Also for the
or
quiz.
sadist professors.
Also for the quiz. Domain is a little more complicated, but done in much the same way. I was feeling generous and didn't make you do a domain on the quiz. Let's tell it to my wife.
Write the letter correct, she got it.
Actually, maybe you don't.
I understand. the
Then she might get suspicious. Any questions?
Nothing.
I have a question. I don't even know how to explain the question. It's like the crazy part. Just give me 1 second. Are you about
Well,
to pass out the quizzes?
Explain the question would kind of be answering the question, wouldn't it? You don't know how to ask the question.
Just like a little bit, I know I keep making you repeat it, but for the stuff that we were doing before like like we had to do the, yeah. When we have to find the domains of fx and fg, what you want to do is, right? I mean, is it like this?
Hear me out and then go silent.
You know, 'cause, like,
I'm saying, when it's time to ask a question, go blank.
yeah, it's like, how do you?
And then you'll get home and you go, oh, that's how I wanted to ask it.
Where it's like, oh, you know? How do you figure out the domain, basically? And can you go over how you will figure out the domain for f of x and g of x?
Depends on the function. Right now, there's just 2 questions you want to ask yourself. Is there a denominator? If there is, it can't be 0. So you take out values where it's 0. Second question, is there a radical? If there is it even or odd? If it's even, then what's under the radical cannot be negative. That would be important. It is not important.
Whatever is negative under the radical is the.
So anything under an even radical cannot be negative. So you'd have to
That would be excluded.
solve for what's under the radical greater than or equal to 0. Right, and then if it's under the denominator, you just take, if it's in the denominator, you just take out values where that denominator is 0. There will be other rules when we learn other functions, but for now, those are the 2 rules to keep in mind. An even radical, right? Square root, 4th root, 6th root has to be non-negative, greater than or equal to 0. Now I'll divide by 0. Because if you do, the universe blows up. Any other questions? Another very easy quiz, in my opinion.